Question 13 reads, ABCD is a square with AB equals 12 units and P is an interior point whose distance to A, B, and CD are equal. So we know that A to B is 12. And we know that from point P, A is equal, B is equal, and the point C, D is equal. Now we have to figure out how all these are the same, or how we can find out what the distance to P is. There's a really simple way to do this. First, we're going to cut this in half. Alright, now you see we have a right triangle. So now we can use Pythagorean theorem. So instead of this being 12, we know that the point from the midpoint here is 6, and this is 6. Alright, and we know that all these are the same. So we'll call this x, we'll call this x, and we'll call this x. So now let's set up our Pythagorean theorem. We're going to go with 6 squared plus this question mark, I don't know what this is yet, squared, equals x squared. But we do know what this question mark is because it tells us this is a square, so we know going through here that this is 12. So this point, or this line segment, must be 12 minus x. So now we have 6 squared plus 12 minus x squared equals x squared. Alright, let's solve for that. Let's erase all this. Alright, so I have 6 squared plus 12 minus x, that whole thing squared, equals x squared. 6 squared is 36. We're going to FOIL this out. We'll get 144 minus 24x plus x squared equals x squared. Subtract x squared from each side. Those cancel out. So we have 36 plus 144 minus 24x equals 0. Add 24x to both sides. So we have 24x equals 36 was 144, which is 180. Divide by 24 on both sides. X equals 7.5. So the distance from A to P, B to P, and P to line segment CD is 7.5. C.